Now let's talk about the mean value theorem. Let f of x now be a function that is defined on an interval, a closed interval now, a comma b. If 1, f of x is continuous, on a closed interval ab. Second aspect is that if f of x is differentiable on an open interval a comma b, this theorem does not have the third part. It does not care whether f of a is equal to f of b. So if just these two conditions are satisfied, then it says that there exists a number c, which is also a member which lies between a and b, such that f prime of c now is the same thing as f of b minus f of a over b minus a. You see this right hand side is called the second line. The second line now is the same thing as the tangent line, because this left hand side is talking about the slope. So how do you represent this on the graph? Let me do the graphical representation of this theorem for a better understanding. Let's assume we have a curve, just like the first theorem, the Rolle's theorem. And this is my A, while this is my point B. Now, the first condition that you need to check for is that, is it continuous? Since it is smooth and there's no break, so we can say that f of x is continuous. What about the second one? Is it differentiable? Yes, there is no vertex, there is no problem, it is differentiable as well. F of x is differentiable. Now, do not forget I said it does not actually care about f of a and f of b, whether they are equal or not. So in this case, you can see that f of a is not the same thing as f of b. F of a is not the same thing as f of b. But mean value theorem does not care about that. All it cares about is these two conditions. So if these two conditions are satisfied, then it means that there exists. Now look at the second line. The second line is still the same thing as saying that these 2 points, point A comma f of a and the point B comma f of b. That's the second line. And where are those points? This is the first point, this is the second point. So you just join the two lines together. This is the second line. So it now means that there exists a number c that is also part of that interval, such that c exists somewhere around here. The slope that you get with this value c is going to be parallel to this line. You are going to get something like this. Don't mind my straight line. So it means this line is parallel to this line. So it means this is our f prime of c. So there is a value c here that is in between a and b. Let's solve some problems under this. Since this is a polynomial function, so it means that the first condition and the second condition are met, which means that it is continuous and also it is differentiable. Our conclusion, means that there exists f prime of c such that f of b minus f of a over b minus a is equal to f prime of c. Now, what is our a? Our a is 1 and our b is 5. So it means we are testing for f prime of c, where the value of f prime of x will give us the right hand side. What is the f prime of x? What's the value of f prime of x? F prime of x will give us 2x minus 4. So now we are going to equate 2x minus 4 with the right hand side. That is f of 5 minus f of 1 over 5 minus 1. If you solve this carefully, see that f of 5 will give you 6. That's 25 minus 4 times 5 is 20 plus 1. So we have 6 minus f of 1 plus minus 2. So you can see this, that 2x minus 4 equals 6. And this gives us 6 plus 2 is 8 over 4. 2x minus 4. And that gives us 2. Which implies that 2x minus 4 equals 2. Then 2x equals 6. And x equals 3. It means that our c equals 3. So that point on the graph, where the second line is parallel to the slope, one of them, actually, it's possible we have more than one, but MVT is telling us that at least there is one point that will give a slope that is parallel to the second line. Let's look at another example. Check if mean value theorem is applicable to this function. Let's check, is this function continuous? Considering this closed interval. Yes, the function is continuous. There is no point where the value of x from 0 to 2 will be undefined. If you set x to be 0 to the power of 1 over 3, you always get a real number. Till you get to 2, you always get a real number. But what about the differentiability? Is it differentiable? Let's check. If you differentiate this, you get 1 over 3x minus 2 over 3. This is the same thing as saying 1 over 3x to the power of 2 over 3. And at the point where x is equal to 0, this will be undefined. So for this reason, this is not differentiable. Now, it is not differentiable at the point where x is equal to 0. And don't forget, we are testing differentiability on an open interval. Because we are testing it on an open interval, this 0 is not even actually part of the numbers in consideration. 0 is not part of this interval. So for that reason, we neglect this. Whether it is differentiable on 0 or not. Had it been it is not differentiable at the point where x is equal to 1, then we should be concerned. But in this case, we shouldn't be concerned whether it is differentiable or not at the point 0 or at the point 2, because they are not actually part of the interval. So it means these two are satisfied. It is differentiable on every other point in the interval except the boundary, which is not part of the interval. So we can go ahead to conclude that f prime of c is therefore the same thing as f of b minus f of a over b minus a. Now, if this is the case, which is the same thing as f of b, where our b is 2 minus f of 0 over 2 minus 0. Now, what is our f of b? You slot in the value, you have 1 point this over minus 0 over 2, which will be the same thing as approximately 0.63. So it means that if you are going to equate the left hand side to the right hand side, you have 1 over 3 x to the power of 2 over 3 to be equal to 0.63, and you have 1 over 3 into 0.63 equals x to the power of 2 over 3. And this will give you 1 over 1.89 x 2 over 3. While this will be x raised to the power 2 over 3 equals 1 over 1.89. And the value of x will give you the cube root of 1 over 1.89, which is the same thing as 1 over the cube root of 1.89. And that's 1 over 1.236. So our final answer is x is equal to 0.809 approximately. If you find this video helpful, subscribe to this channel, comment, like, and share with your friends.